position. This is fixed to the housing, so as it's moving up, the distance between the sensor and the plunger itself would increase due to the cone form, the conical form of the umbrella seal. We can see here that we have a piston, the actuator piston, or sorry, the hydraulic piston here with the seam with backup rings, and we can see that we have the sealer here for the so we do not have cross-contamination of the two systems, i.e. the fuel and the exhaust valve. No, the fuel and the hydraulic power supply system. Looking at the throttle valve, which is mounted on the base of the housing of the fuel oil booster shown here. Inside that we have this throttle valve where we can see we have a pin, a needle and spring set up. Every time we have an operation of the booster, i.e. the hydraulic piston moves up, then we have, and you can see just about here, the channel, not shown here, the channel will drain any pressure oil and of course any possible air bubble buildup or air pressure buildup in here, drain it off through the throttle valve. Excuse me. There are two designs of the throttle valve. Excuse me. Two designs of the throttle valve. You can see here, this is one design and another one with a larger spring depending on the size of your engine. And the newer design, sorry, not the new design, the latest design is that we have, instead of using a throttle valve, we use an orifice. So we drill a specific hole, dimensioned hole, for the same function as the throttle valve. So we have a constant bleed. It will bleed back to the drain line, so there is no leak, there's no spray, there's no collection pot. It will go back into the drain part of the system. The plunger itself here we have a fuel oil plunger. We can see that we have the plunger, and as you get close to this stem part, we see that we also have some grooves on the plunger, and this is to trap the fuel oil. So as it's moving through the housing, if you can see that, so as it's moving through the housing inside here, it's lubricating the movement of the piston. Then we see that we have the shape of the conical, the umbrella seal shown here, and if we can just about see how the form of this, so we can just about see the, not a very good one, there is a slight conical form here, and then we would have this feedback sensor shown here. This is just a damaged feedback sensor mounted into the housing. So as the plunger moves up and down, then of course the distance between the feedback sensor would increase. Therefore, the system then knows where the plunger is. This is why when you are, or if you have to change the feedback sensor for the plunger, you need to calibrate the feedback sensor using the function test on the mob screen, so the system then knows whatever the position of our plunger at any time as well. Okay, gents, are there any questions to that? Yep. Then the question. Yep. Then the suction valve. Suction valve here, we would do what it says in the manual. We would check the function and the integrity, if it is a secure closing of it, i.e. if the spring tension is there, or if there's any major wear on the mating surfaces here. We cannot grind this or lap it anymore. The surface is that hardened, so it will probably cause more damage to the machine, and then of course some unnecessary damage to the actual mating surfaces. So following the procedure in the manual, you need to check and make sure that it is fulfilling the requirements, and if it is doing that, then everything is fantastic. If not, then you need to replace the whole unit. You cannot just replace the spring or the top hat or the conical securing plates anymore. So that was the fuel oil booster. Pretty straightforward, not a lot of moving parts. So are there any questions to what we've just covered?
So the inductive sensor on the exhaust valve and the inductive sensor on the fuel oil pressure booster, are they both interchangeable or they are same type?
They are not interchangeable due to the difference in the length of the sensing rod on the actual feedback sensor. So if we look here, the housing for the fuel oil booster, this part here, so it may look like it's interchangeable from the outside, but the part from here to here are a specific length. So if it's too short, it won't read here. It won't sense either the movement of either the fuel plunger or the exhaust valve. If it's too long, then you're going to cause damage. Okay, so they are specific to the components, i.e. for your exhaust valve or your fuel oil booster. Okay.
Yeah, okay.
Cool. So looking at the exhaust valve, now we can see over here on the left hand side we have the MC, we have the actuating gear for the exhaust valve. Over here we are looking at the exhaust valve actuator and the exhaust valve itself. Not a lot has really changed with the exhaust valve in regards to the movement. It still goes up and down, opens and closes. Some small design changes on the top part for the ease of operation and the power economy and the power used for the operation itself. Otherwise, we charge the hydraulic push rod to open the exhaust valve and decay the pressure to close it. The exhaust valve actuator itself, again, similar to the fuel oil booster, pretty simple, not a lot of moving parts. Two pistons, 1, 2, inner, outer, moving up and down for the operation of the exhaust valve. Top cover, mini-mesh connection and housing to give us a full operation. So we can see here we have the initial position, I at the bottom, where we have both inner and outer position in the lower point or the 0 point. Then as we are going to charge the push rod, we have pressure from the hydraulic power supply system via the hydraulic cylinder unit with the FIVA valve operation, moving the inner and outer piston to this point here. When the pistons have reached this point, step 1, then the inner piston will continue to travel in the opposite motion, charging and continue to open the exhaust valve. The idea behind the two-step piston is to remove, remove any fluctuation or any cavitation within the hydraulic push rod for the exhaust valve, therefore having a nice smooth, a more smoother and accurate opening operation of the exhaust valve. So the designs behind the exhaust valve, here looking at the high force, in the beginning we were concerned about the pressures in the newer engine, so we had a design for the high force, so we wanted to make sure that we're using a lot of pressure, a lot of force, high force, to open or for the operation or the opening of the exhaust valve. So looking at the top part here, we can see that we have the sealing oil control unit. And we can see that we have a self-adjusting damper piston. So for the closing operation of the exhaust valve, so we have this piston here, so we don't have a slamming shut. We have a hydraulic